Hey, welcome back to the workshop. For today's project, I'm going to make a 6-inch chef's knife out of this piece of AEB-L stainless steel. I've been experimenting with simple chef knife designs. I'm really just concerned with how the shapes of the blades perform, so I'm not getting crazy with the handles. I think I'm going to make this top one here to start with. I may make some of these other ones later, but for right now, this is where we're going to start. Alright, the first thing to do is get this pattern cut out and transferred over to the bar of steel. A lot of guys like to stick the paper pattern to the steel with a spray adhesive instead of tape. This allows them to cut the knife out with the pattern directly on the steel. I don't like doing that because I may want to use this pattern again someday. If I apply spray adhesive, then the pattern can't be reused. Tracing out the blade shape with a marker gives me a nice wide margin of error for cutting out the knife. Cuts made on or outside the blue line are safe. Cuts made inside the blue line are bad. I'm not super accurate with the metal cutting bandsaw, so I like to know that I'm giving myself a bit of a safety margin. This does leave a little more metal to grind later on, but I'd rather have too much left than too little. Now it's time to move over to the metal cutting bandsaw and cut out this pattern. I'm using a DeWalt Portaband saw in a Swag off-road stand. I get a lot of good use out of this setup, but it is somewhat limited in its ability to cut tight curves. After the rough knife blank is cut out, the cut marks and rough edges get cleaned up on the grinding wheel and the belt sander until the final outline of the knife is complete. Next, the 1/4-inch pinholes and a series of smaller glue bridging holes are drilled in the handle of the knife. For drilling steel, I find that a sharp drill bit is more important than a hard drill bit. I've set my drill press to its slowest speed, and then I use firm, even pressure to make my holes. The drilled holes do develop a sharp burr at the edges, which I sand smooth again with a 120 grit belt. Okay, so I've got the chef knife all cut out, but I don't have the bevels started yet. And I think that for this knife, because it's a little bit longer than knives I usually make, and quite a bit thinner in spine thickness, this piece of steel is only 0.1 inches thick, 1/10 of an inch, which is pretty thin for a lot of knives. I think I'm going to heat treat this first, and then grind it at full tempered hardness. Leaving it thick should help prevent warping when we go to quench it, which is always a risk you run. One of the most difficult things for a home knife maker to do is determine the hardness of a knife. To help out with this, I use a set of Japanese Subosan hardness testing files. In 2020 dollars, this file set can be found on Amazon for slightly less than $100. Or, if you just like spending money, the same set can also be purchased from several knife maker supply sites for well over $100. Anyway, this isn't an exact science. The results are a bit subjective, but I believe this is much better than nothing. By testing my blade before heat treatment and testing it again after, I can know with absolute certainty that my knife has achieved at least some hardening, which I find difficult to determine with other methods such as the file skate test or the ball bearing drop test. At this stage, the untreated steel comes out to what I have determined to be a Rockwell C hardness of between 45 and 50. After the heat treat, I hope that it comes out much harder than this. 45 to 50 is too soft to make a good knife. I think we can do better. I'm using a heat treatment recipe for AEB-L steel that is sort of a hybrid between the method given at Alpha Knife Supply, where I purchased this steel, and another method detailed on the website knifesteelnerds.com. Links to both of these will be available in the description below. But in general, I'm trying to slowly heat the steel up to about 1560 degrees Fahrenheit. Hold it there for about 5 minutes, then quickly ramp the heat up to between 1940 and 1975 degrees Fahrenheit. Then hold it there for a further 15 minutes. Then I'm going to quench it in pre-warmed, somewhere above 100 degrees canola oil. This method has given me pretty good results in the past. Quenching stainless in canola oil does leave the blade with a hard black surface scale. This needs to be ground off before the quenched hardness can be checked with the files. The quenched canola oil scale can mostly be removed with a high-speed brass wire wheel before moving over to the belt sander. It is important to remove the bulk of the scale on the wheel first, because the scale is somewhat oily and sticky, and it will quickly clog up the sanding belt. After the oil quench, the new hardness of this knife is between Rockwell 60 and 65. After quenching, ideally I would place this blade in a bath of dry ice and acetone to bring the temperature down to below -95 Fahrenheit, which should provide a slight increase in overall hardness. But I don't have any, so even putting the knife in the kitchen freezer for a few hours seems to help a little bit. After quenching and freezing, the knife moves over to the toaster oven for tempering. I'm tempering this blade at 350 degrees Fahrenheit for 2 cycles of 2 hours each. If everything has gone well, this should result in a very hard, very tough knife. According to the testing files, the final tempered hardness of the knife comes out to somewhere between Rockwell 60 and 65. This illustrates the limitations of the files, because we know that after tempering, the blade should be somewhat softer than it was at the quenched hardness. However, my files aren't fine enough for me to see the difference. We just have to trust that it's somewhere within its desired range. Finally, it's time to start grinding in the bevels. The first thing I do is set the edge by grinding in steep 45-degree angles. All of the bevel grinding will be behind this line after this, so that the edge profile isn't lost. I do the bulk of the grinding with a 60 grit ceramic belt, starting with a short bevel and slowly working the line back until I have a full height flat grind. Then I move up to an 80 grit belt and finally a 120 grit belt. I would go farther than this, but I'm all out of finer grit belts right now. So after the 120 grit, this knife is going to have to be finished by hand. For this knife, the total grinding time probably took me about 3 hours. I use the wet method for hand sanding my knives, and I spray it down with a mixture of dish soap and water. I used to use WD-40 for this, but I've found that soap and water works just as well and is probably way better for you in the long run. Hand sanding is always the longest, most frustrating part of the knife making process. Because no matter how good you get, you always get to a point where you think you're all the way done, and then you go and you look at the knife in good light and you find out there's still a bunch of scratches all over it. Then you find out you're not done at all. This knife will be getting handles made of 1/4 inch thick G10. I really like G10 for a kitchen knife because it's waterproof, impact resistant, chemical resistant, heat resistant. It's all around just a very tough material. The one drawback to G10 is that it's very heavy. Using G10 on this knife is going to make the knife somewhat handle heavy. That can help you or hurt you depending on the desired balance you're trying to achieve with your particular knife. I like to glue up all of my knife handles with West Systems G-Flex marine grade epoxy. When applying epoxy to the handle scales, I try to apply an even coat all across the surface of the handle. This leads to a lot of squeezed out glue, which will need to be cleaned up later. But at least then I know I've got a good solid glue joint everywhere around the entire handle scale. If this is done well, then no water or food juices can ever get in under the handle, which I think is important for a kitchen knife. The knife is then clamped and the epoxy is allowed to cure for a full 24 hours. At this point, the knife handle is almost done. If you've done a good dry fit with your handle scales, you shouldn't need to do a whole lot of cleanup at this point. Really, it just needs the excess glue sanded off and the corners rounded. But this is a real simple handle. A more complex handle shape is going to require more work. Now it's time to sharpen the knife. Normally I would do this with my set of Japanese water stones. But my main stone is pretty well wore out, and I don't have a new one to replace it yet. So, in the meantime, this knife is going to get sharpened with the old Lansky kit. Well, the knife seems sharp enough to cut paper. That's good. But if you make a kitchen knife, I guess you gotta cut some tomatoes. Well, that kind of works. I mean, it's pretty sharp. I'd say that's working sharp. Maybe when I get some more water stones in, we'll come back and touch this up and it will be better. I'd say this knife cuts well enough to make me happy, but when I compare it to other videos that I've found, I can see that it could still perform a little bit better than this. But, I'm still kind of new at this, and I'm still learning as I go. The next one will be better. This one was pretty good, but there's always more room for improvement. Well, alright, I think that just about does it for this one, so I hope you found that interesting, and I will be right back here in the workshop with another project just as soon as I can. See you then.